Okay, so we are done with the mathematical part of this cryptography, and today we'll start discussing cryptography. Right, so we will start with its definition and its basic, and then we will discuss some techniques for cryptography, the techniques which we use for implementing cryptography. Now cryptography, as we discussed in some initial lectures also, that cryptography is what? This is the art of secretly writing a message, right? So and this message which we are sending over the network, which which could be attacked, which can be accessed by some intruder. So that message will be written secretly in a form which cannot be accessed easily by some intruder. So that is the concept of cryptography. Now, and that is the same thing it is saying, that we send the information in a way that prevents others from reading it. And along with this secret transmission of or the secure transmission of data, cryptography ensures the integrity of the data, which means that no unauthorized changes will be done to the data while transmitting it. And authentication also is ensured by this cryptography, which means that only the authorized users would be able to access the data. Okay, so this is how we encrypt and decrypt the data while implementing cryptography, because cryptography means you are encoding the message in a form which is not accessible easily, okay, while we transmit that information over the network. So these two operations are done on the data, which is encryption and decryption. So how do we do that? So here, this is the sender side, okay, this is, say for example, A. This is the receiver side, which is B. So at sender we have this plain text initially, right, and this plain text with the help of some encryption technique will be converted to the ciphertext, right, and then it will be sent to the receiver, wherein this encrypted message will be decrypted so that the receiver B receives the original message which A has sent, right. So this is encryption and decryption. Now for implementing this encryption and decryption, we need a value, a secret value, which we call as key. So the key which A uses, we call it as KA, and the key which B uses for decrypting the message, we call it as KB. So these keys, these both keys, they can be same or they can be different. So on the basis of this thing, that these keys are same or different, we have two cryptography techniques which are called symmetric and asymmetric cryptography, which we will discuss later later today. Okay, next we will go through some terms which we will be using throughout the semester for explaining the things in a better way. So most of these terms are which the terms which we have seen here in the previous slide. So first term is plain text, which is the original message which the sender is sending to the receiver, which for in our example, A is sending to B. Next is ciphertext. Ciphertext is when you encrypt this plain text. So after this encryption process, you get ciphertext, right? So this is the message in the transformed and unrecognized form. So this is the message which we transmit over the network, so that it cannot be read easily by the attacker. Next term we use is encryption or encipher. Encryption is the process to change the plain text to ciphertext, okay, and to change it we apply this algorithm which is called encryption algorithm, and we also call it a cipher. Okay, next, in contrast to this encryption we have decryption, which we call as decipher, which will be the reverse of encryption process, in which we will be getting, or we will be finding out the plain text out of cipher text. Next thing we have is key. Now key is a secret value which will be used by both sender and the receiver, and it will control the encryption and decryption, the whole process of encryption and decryption. And both, as I already told you, that both sender and receiver, they need to know the value of key. Next thing is the cryptography. This is the definition, simple definition of cryptography, because these three things are related to each other, so that is why we have again included it over here. The cryptography, this is the study of encryption principles and methods. So this will include all the methods and techniques which we apply to data for encrypting it. Next comes cryptanalysis. Cryptanalysis is code breaking. So it will tell you about the attacks or the methods which are done deliberately to check that how secure the data is, how secure mechanism we have applied to data to get the cipher text. Okay, so this is the study of principles or methods of deciphering the cipher text without knowing the key. So this cryptanalysis is done deliberately by the persons or the organization which has done this, which has implemented this cryptography to some particular data, to see that that particular data is how much prone to the attacks. So we will discuss a number of a kind of the attacks which can happen when we transmit the data. Next comes cryptology. Cryptology is the combination of cryptography and cryptanalysis. So when we combine both of these two things, then we say that we are talking about cryptology, right? So these are the terms which we'll be using throughout the course. Okay, next is these are the types of cryptography functions or the techniques. So two main techniques we have over here. We have other techniques also which we will discuss later in this course, but for now you need to understand these two types. One is symmetric cryptography, another is asymmetric cryptography. The symmetric cryptography is also known as secret key cryptography or conservative cryptography also. It uses only one key for sender and the receiver. So sender and receiver, they both will be using only a single key. In asymmetric cryptography, two keys will be used. One key will be public and another key will be private. Okay, so now we will be discussing these techniques or these types of cryptography, which is symmetric and asymmetric, in detail. Okay, so this is secret key cryptography. So as I already told you that we use a single key for secret key cryptography. So here we have this plain text, and after encryption with the help of this key we get the cipher text, and with the help of decryption, by applying decryption methods, by using this value of key, we get the plain text at the receiving end. So here you can notice that the key which is being used at the sending end and the receiving end, they are same keys, right? So that is why we call it a secret key, and this key is known to sender and receiver only. And so we call it private key cryptography also because of this reason. So here the same thing is written over here. The same key is used for both the operations, which are encryption and decryption operation. We call it symmetric cryptography also, conventional cryptography also, private key cryptography, because we use only one key. So if you see any of these terms anywhere, so don't get confused, that is the same thing, right? But the general term which we use for this kind of cryptography is symmetric cryptography. Okay, and the ciphertext is about the same length as the plain text when we encrypt the data using this symmetric cryptography. These are some examples which we'll be discussing in detail later. Okay, next is public key cryptography. So here the process is same. From plain text, with the help of encryption algorithm, we will be creating the ciphertext, and at receiving end, with the help of decryption, we will be getting the plain text. But here the difference is in this key which we are using over here, right? So this is the public key through which the message is encrypted. Now public key means this key is accessible to everyone out there. But at the receiving end, we are using this private key. So this key is known to the receiver only, right? So the concept of this public key cryptography was invented in 1975, but actually its use came into light in 97. Okay, so it has in this kind of cryptography we have two keys. One is private, which is kept secret, and another is public, which is publicly known. This is much slower than secret key cryptography, which is the previous version of cryptography, and it is also known as asymmetric cryptography. So these are basic two techniques of cryptography, which are symmetric and asymmetric, and we give this name on the basis of keys we use with these techniques, right? Symmetric we call it because we use the same key for both the ends, and asymmetric we call it, why? Because we use different keys for sender end and for the receiver end. Okay, so now we will be discussing this symmetric key cryptography or symmetric key cipher in detail, and for this we will be covering these three topics, right? One is this Kerhoff's principle, we'll be talking about this, then cryptanalysis, and then the categories of traditional ciphers, which comes under symmetric key cryptography. Okay, so here we'll be using these persons as sender and receiver. So Alice will be the sender and Bob will be the receiver. So we will consider, or we will assume, that Alice will be sending the message. Alice will be having the plain text. It will be converting that plain text into cipher text using the encryption technique, and will send it to Bob, which will then decrypt the message and will get the plain text, and they both will be having the information about the key which will be used in this data transmission. So the original message which Alice will be sending to Bob, we call it plain text, and the message that is sent through the channel is called the cipher text, because Alice will not send this plain text as it is. Alice will apply some cryptography technique, some encryption algorithm, and will change this plain text to cipher text. And to create this cipher text from the plain text, Alice will use some encryption algorithm and a shared secret key. Now why is this shared secret key? Because this is the symmetric key cipher or symmetric key cryptography. Now to create the plain text from cipher text, Bob will use a decryption algorithm and use the same secret key which Alice has used for encrypting it, right? So this will be the process, and this is represented with this beautiful diagram over here, the symmetric key cryptography. So here you can see this is Alice who is sending the message, and this is Bob who is receiving the message. Here the intruder has not come to the light right now, so we'll talk about the intruder also in the later slides. So Alice is having this plain text, and on this plain text some encryption algorithm will be applied with the help of this key, which is shared by both the sender and the receiver. And after applying this encryption algorithm with the help of this key, we get this ciphertext, and this ciphertext is transmitted over this channel which is insecure, and will send it to the receiver, which is Bob. Now Bob will get the ciphertext over here. Now decryption algorithm will be applied to this ciphertext with the help of this key, and as a result we will get this plain text. Okay, so Bob will be able to read this plain text, but here in between some attack could happen, so we have to take care that this attack does not happen over here, right? Okay, so this is the mathematical part, or the representation part, I must say, that how do we represent this encryption thing and decryption thing. So this is the encryption. Here P is the plain text, C is the ciphertext, and K is the key. So while we encrypt the message, what we get as a result? We get the ciphertext as a result. And how do we get that? We will be applying the encryption to the plain text. This E is encryption, P is plain text. So we'll be applying this encryption to the plain text with this key, and as a result what do we get? We will get the ciphertext. For decryption, as a result we'll be getting the plain text, and how do we get it? We will be using this ciphertext. We will be applying the decryption technique to this ciphertext with the value of key. So this is how this encryption and decryption they are performed. Okay, here you can see that when you apply decryption to an encrypted message, this is the encrypted message. So when you apply this decryption to this encrypted message, then and if you apply encryption to the decrypted message, then you will get the same value of the message, which is X, which is the original message, right? So this condition satisfies for these two expressions, right? So we assume that Bob creates P1, and if we can prove that P1 equal to P, because P is the original plain text, and P1 is being produced by Bob, which is at the receiving end here, right? So if we prove that the message which is produced by Bob is equal to or same as the message which was sent by Alice, then we can say that this encryption and decryption thing, it worked well, right? So we can prove it using these expressions. So Alice has sent this message. It has encrypted the message. It has created a ciphertext using this expression, which is this one, right? So Alice has created this message and this ciphertext. Now Bob is having P1, and at the Bob end, what we are having? We are having this message, this one, right? So P1 is equal to DK, that means the decrypted version of the ciphertext, right? So if we replace this C with this value, which was sent by Alice, so what do we get? We get this expression. So this expression will give you value P, and this we have concluded from where? From here, right? So here we can say that P1 is equal to P. Here this is P1 which is equal to P, right? So we can say that these techniques of encryption and decryption which we have used over here, they will let you access the original message even after encrypting it and decrypting it. Encryption at the sending end and decryption at the receiving end. Okay, so this is just simply a representation of the symmetric key cryptography. So here we are using the same key. So encryption algorithm will do what? It will just lock your message, okay, so that no one can read it. And decryption algorithm will do what? It will unlock the message so that the receiver can read it, right? So this is the unlocking and locking thing with the same key. Now what does this principle, which is Kirchhoff's principle, says? It says according to this principle that it says that any intruder must if any intruder wants to access any message which is being transmitted, then there is no need to focus on encryption and decryption algorithm. We must secure the value of the key which we have used for encrypting the message and which will be using for decrypting the message. Okay, so it says that the resistance of the cipher to attack must be based only on the secrecy of the key. So if the encryption and decryption technique is available to anyone out there, that should not be a thing to concern, right? So in other words, we can say that guessing the key should be so difficult. It should be so difficult that if this encryption and decryption technique, if they are known to everyone out there, then we should feel no danger in that, right? So the value of key we should choose such that the intruder cannot break it easily or cannot find out the value of key easily, even if the encryption and decryption algorithm is available to intruder. Okay, so that is the essence of this principle, that we should focus on key only, right? Next comes cryptanalysis. Now cryptanalysis, as I told you before, this is deliberate attack which is done to check the level of security of the data which is being transmitted, right? So cryptanalysis is the science and art of breaking those codes which we have made using cryptography. Okay, so cryptography will create the codes and cryptanalysis will be breaking the code. Now why do we do this? We perform this cryptanalysis just to check that when actually we transmit the data over some insecure channel, and if it gets prone to some attack, then how would it behave, right? So we this is just the testing part of the data, okay, for which you have applied some encryption technique. So there can be these four kind of attacks. When we talk about cryptanalysis attacks, we check the data from a point of view of these four attacks. One is cipher text only, then known plain text, then chosen plain text, and then chosen cipher text. Now we'll discuss all these attacks one by one. Now this is the cipher text only attack. Now in this kind of attack, the intruder Eve comes here, which is the intruder which is trying to access the message which Alice is sending. Okay, so what this Eve will do, it will simply analyze the ciphertext which is being sent by Alice. Okay, so it will just try for every match for this ciphertext and will try to create a corresponding plain text for it, which will be meaningful. Okay, so here we this Eve will have access to the ciphertext only, which is being sent by Alice to Bob, and it will analyze that ciphertext and will test and try which of the plain text matches it very well. So that is why it is saying it goes for exhaustive search until some recognizable plain text it finds, right? So this is one kind of attack which Eve can plan. Now this is another kind of attack which is known as known plain text attack. Now in this kind of attack, what happens that Eve gets this ciphertext, okay, but along this ciphertext Eve has access to some of the previous messages which was sent from Alice to Bob, and these messages are they are in pairs as in this is the plain text and this is its corresponding ciphertext. So on the basis of the concept behind this pair, concept means that how this ciphertext is created for this plain text, right? So it will try to use the same method for converting this ciphertext to some plain text. Okay, so if Alice is using the same key which she has used for encrypting this particular message, for which Eve has all the information. So Alice has if Alice has used the same key for this ciphertext as well, so it will not be difficult for Eve to crack its plain text for this given ciphertext, right? So this is known as known plain text attack from Eve, in which the main thing is obtaining this pair, this previous pairs which were sent by Alice to Bob. Okay, next kind of attack we have is chosen plain text attack. Now in this kind of attack, Eve has access to the system of Eve, okay, and from here it can find out the pairs of plain text and ciphertext, and in the same way it can apply the same method to this particular ciphertext which it has accessed while transmitting, and will try to obtain this the corresponding plain text to this ciphertext, right? So the difference is यहाँ पे क्या होगा, Eve has access to the system of Alice, but in the previous example, in the previous kind of attack, Eve does not have access to the system of Alice but has some previously sent messages, right? Now this is the chosen plain text attack. Okay, so this will be useful if some limited set of messages are sent from Alice to Bob. Now the last kind of attack we have is chosen ciphertext attack. Now in this kind of attack, this Eve will have access to system of Bob, right? So here, from here it can find out this pair, okay, which was sent to Bob from Alice, but here our focus is on ciphertext because we are changing the ciphertext to plain text. In the previous example, we were changing the plain text to ciphertext. So here as well, Eve will try to implement the same process which was implemented over here to this ciphertext, and will try to get this plain text. Okay, so these kind of attacks could happen. One more attack is there, which is tested for security purposes, which is called brute force attack. So brute force attack, we also call it exhaustive key search attack. It involves trying every possible key until an intelligible translation of the cipher text into plain text is obtained. So we will try, or the intruder will try each and every combination or value of the key until it receives any meaningful message out of the cipher text. Okay, so that is why we call it brute force or exhaustive key search method. So it says that on average half of all the possible keys must be tried to achieve success. So it takes a lot of time to check for all of these values of keys to find out the right value of key. So a cipher or any encryption algorithm must be secure against all of these attacks which we have just discussed. Okay, so next topic is traditional ciphers. Okay, so these traditional ciphers will discuss now, and these traditional ciphers, they include a number of ciphers which are substitution cipher and transposition cipher. So right now we'll be discussing this substitution cipher. Okay, in this substitution cipher we have these two kind of ciphers which are mono-alphabetic and poly-alphabetic. Now in substitution cipher, what do? We replace one symbol with another symbol. Say for example, if I need to send a message, say hello. Okay, hello is to be sent. So instead of sending hello, I will replace this H with some other alphabet. I will replace this E with some other alphabet. I will replace L with some other alphabet. Now in this substitution cipher, there will be only one replacement. This replacement will be 1 to 1 only. Okay, so if we are having these multiple alphabets, multiple same alphabets in a word, then all of them will be replaced by a single value. So if here this L is being replaced by R, so each and every L will be replaced by R only. Okay, so next this O will be replaced by any other alphabet. So instead of sending hello, I will send this message, this replacement which I have done over here, right? So that is why we call it substitution cipher, because we replace one symbol with another. And these two kind of ciphers we have in substitution ciphers. Now in mono-alphabetic ciphers, what do? As I already told you, that the relation is 1 to 1 between the symbols of plain text and the cipher text. So this is the same thing that is telling you that the relationship between the symbols in the plain text and the cipher text is 1 to 1. Okay, so this is the example to make you understand it in a better way. So say for example, we are sending hello. This is the plain text, and what we are doing is we are replacing each character with some another character. So here H is being replaced by K, E is being replaced by H. Now here you can see both L are being replaced by O, right? So by looking at this message, we can say that this cipher text we have got by using this mono alphabetic method, right? And this again, this O is being replaced by R. Now this replacement shows you that this is not mono alphabetic. Why? because here these both of these L are having different values over here. So we cannot say that this cipher is following mono alphabetic way, right? Okay, so this additive cipher, okay, so we'll talk about this in the next class. So for now this is done.